Welcome back, guys. We'll be solving more examples on limits. Let's get started. The first example I have here is limit and x goes to 2, x cube plus x plus 1. So x tends to 2 here. So we have, like I told you in the previous video, we have to replace our x with 2. Here we have x. Now we'll be replacing it with 2. We have two cube plus 2 all over 2 plus 1. It will be 8 plus 2 over 3, which is equal to 10 over 3. See, it's as simple as that. That's our answer. Then the other example I have here with me is limit x tends to minus 1 x squared plus x plus 2 all over x squared minus 4. Same thing, we apply the same method here. Regardless of what x is tending to, even if it is 0, you just have to replace all x with 0. But in this case we have minus 1. X is tending to minus 1, so we have to replace all x here with minus 1. So we have minus 1 squared plus minus 1 plus 2 all over minus 1 squared minus 4. Now this will give us 1 minus 1 plus 2 all over 1 minus 4. So our final answer will be minus 2 over 3. It's as simple as that. Let's solve more examples. Third example. In this example, we'll be solving trigonometric functions, where we'll be dealing with tan, sine, cosine, secant, and so on. In the first example, I have limit x tends to c sine x. Our answer is sine c. Why is it c? I told you that anything x is tending to, you just have to replace it with x. Because x is tending to c, so you have to replace this x with c. That's how we got this c here. Another example, limit x tends to c cosine x. This one too is very easy, just cosine c. Then another one, limit x tends to c tan x. Is still the same thing, still tan c. Regardless of the trigonometric function, you just have to replace it with our function here, which is c. Even cot, we have so many other stuffs here, like cot, we have secant, and so many others. You just have to replace it with what x is tending to. Another example here, we have limit x tends to pi over 2. Don't get freaked out. This one is still the same method you apply. We have pi over 2 sine of x. So it will be equal to sine, just write this sine. Then our x here, x is tending to pi over 2, you put your pi over 2. So sine pi over 2 is always equal to 1. Another example, 7. Limit x tends to 0, sine x over cosine x. Same thing is applicable here, sine, place it with 0 over cosine 0. Have it in mind that sine 0 is always equal to 0. Cosine 0 is always equal to 1. So what would this answer be here? Sine 0 is 0. That will be 0 over cosine 0 is 1. 1. Which is equal to 0. Which is equal to 0. Another example. We have limit x tends to pi over 4 tan x. Do the same thing here. It will be tan pi over 4. Tan pi over 4 is always equal to 1. Then the last example, we have limit x tends to pi over 4 cosine x over sine x. Then same thing to be cosine pi over 4 all over sine pi over 4. Then here we now have cosine pi over 4 is root 2 over 2, and also sine pi over 4 is root 2 over 2. So it goes here just 1. So our answer was 1. Alright guys, that's all for this video. We'll talk more on limits in the next video.